one and realizing like, oh, I'm not watching any of them. Delete, 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 delete. And then I wouldn't record anymore. So just to let you know, this is when you're going to want to record. There's not a lot of code samples coming today. It's a lot of me talking and showing you stuff on a browser. So I don't have reading for today's stuff really. Like I do, I sent you a reading, but I'm going to be mostly walking through a browser. I think I got everyone. I just, when Daniel comes back, I'll get him. So just let me know if you don't have it. You can't record. Okay. So, okay, so we're creating a new JavaScript promise. So first thing I'm going to do is I'm going to look over yesterday's exercise. And oh, by the way, if I just disappear, it's because website is up. I don't trust it. Let's take a look. If I just disappear, it's because my computer crashes. So, oh, looks like it might be up. Okay, cool. So take advantage of it right now. Everyone go to the website, get your stuff. It's up for now. Okay. Go load the preload the pages in your browser and don't close them. Okay. Sorry. Okay, go preload all the pages that you need in your browser and don't close them. So we're going to be looking today at, okay, I'll go through this stuff. I'm going to preload the pages first. Okay. Sorry. Okay. I'm all preloaded. Doesn't work for you. I'll continue to post stuff, so don't worry. Daniel, are you back yet? No. Okay. That's fine. Okay. So we're going to look at yesterday's exercise. Okay. I'll share my screen, and then we'll head on over to the new stuff for today. Okay. So yesterday again, it's just all about promises. A couple people messaged me yesterday saying like this promise stuff, this asynchronous stuff, it's kind of breaking my brain. I get it, right? We're kind of in that same boat as we were last time where we were learning about object-oriented programming, right? I'm teaching like object-oriented programming, but we're not using it within the context of anything yet. And so it doesn't really make sense. The transition though from object-oriented programming into, when we were doing object-oriented programming, moving from learning about object-oriented programming to applying it was a really big leap for us, right? And I know because I felt that pain along with a lot of you. However, this time, in this case, it's not as bad. Okay, so the first couple classes, we're spending our time learning about promises and asynchronous programming, and you're probably like, okay, I can kind of get it to work, but I don't really get it. And that's totally fine, right? Like once I show you, once you do it a couple times, it'll just like totally become crystal clear. Tomorrow, light bulbs will start going off, right? Like, okay, this makes sense, okay? And again, I'm going to be coming back and referring, this promise, the word promise, that we type in, capital P promise, that's going to disappear pretty much. We're not going to be using it anymore. Instead, we're going to be doing things with promises. And I'm still going to be referring to them like, this is a promise. This is returning a promise. You need to like, so you're going to need to at least understand what that means, okay? But again, everything will clarify tomorrow. So just kind of come with me, bear with me. I'm going to drag you kicking and screaming, okay? But once we get there, tomorrow, Monday, Tuesday, Wednesday, Thursday, Friday, it'll all totally make sense, okay? And it actually leads into something super cool. So, okay. So I will post the solution to Discord, okay? this afternoon, over lunch, I'll get my stuff on GitHub somehow, and we'll start using that. I'll send you a link out. It'll be nice and organized, okay? And then I will keep following up with them about the website. So don't worry about the website. In terms of assignment submissions, we don't have anything right now, but for the first year, I didn't teach with this website. I accept assignment submissions through Dropbox. So I can make a Dropbox request and you guys can send it to me. Don't worry, got it all figured out. Okay, create a new JavaScript promise. Inside, throw a JavaScript error, add a then catch to determine which one will get executed. So this is, again, a lot of stuff that we did in class yesterday. So if you rewatched my video, okay, you would have seen me do this. Let's do a quick save here. Solution. And question 1. So we're just going to do a really simple promise, okay? So we're going to say new promise, and I'm not going to bother assigning it to a variable, okay? I don't necessarily need to. And this promise takes a function with resolve reject as the parameters. Okay. Now, this is my block of code here. All I'm going to do is so we can either reject, hey, rejecting, or we can throw. Okay. Again, I just briefly covered throw yesterday. Both of these things are essentially creating an error. An intentional, it's not creating an error, it's throwing an error. Like, hey, we believe there was something erroneous that happened. Let us alert anyone who might care. And who is anyone who might care? Anyone who might care is a catch. Catch cares. If you have a catch is someone who cares that an error occurred, okay? Or a reject happened. And it will, message or whatever. Remember, you can take in whatever you want here. I'm going to take in message. Okay. And we can just show you, I can show you console log message. Now, when we're throwing, typically we want to throw an error, a teeny bit of information with it. Okay. Just like, I'm an error. So either one of these will cause this console log in the catch to fire. It will cause this catch to catch, okay? If we didn't do a reject or a throw, then the then would be the one responding and the catch would not, right? If it was a resolve or if everything went well, then would act. But catch is catching that error, okay? Or that reject. Both of these are equal. Okay, so if we run this, let's see. It ran the message, okay, so it printed out message. Oh. Oops. Hey, I'm rejecting, okay, so console log that message. If I throw instead, okay, I'm in error, you'll notice we get the same thing. I'm in error. Okay, if I didn't do either of these, will print out, and it's not because it doesn't have a message, right? I can even put a string in here. It's because the catch doesn't even fire, right? So no printout, no error, nothing to catch. Catch doesn't fire. Catch doesn't trigger. Catches are only there to catch those errors. questions on that one?
Do you need the function in then? So I just wrote dot then and brackets. I didn't.
No, you don't even need this.
Oh, okay.
No, you could just have a catch if you wanted to. Yeah, there is no requirement to have a then or many thens or no. Occasionally too, in some readings, you might see this. If you do any reading, like that, just like this. Let's try that. Promise capital P promise dot reject, which is a rejection. Unhandled promise rejection warning high. I have a catch block, do I not? Maybe I do need it then. I don't even think I need that function in there, but okay, now I'm gonna have to double check on my syntax for this. I don't use this very often, but I think it might be this. This is a forceful promise rejection. Undefined is not a promise. Yeah, so you might find something like this inside. It looks something like this. I don't use this ever. I've seen it in readings though, where people, they're not calling, because like inside of a then, there is no such thing as reject anymore, right? That reject function only exists inside this function up here. So it doesn't exist down here, but people want to still reject. And so they'll do something like this instead of throwing a new error, they'll want to do promise.reject. It looks something like this. I'd have to take a quick look in some documentation, but you might see something like that. All that is it's forcing a rejection. That's all it is. Nothing crazy. Okay, I'm going to put this one out there, this piece of code out there as the solution, right? We're going to throw an error, okay, because that's what the question asks. Okay. Number one, create a new promise. Inside the promise, call set timeout. Upon execution, it should call the reject, but this time add the reject as a second parameter to the then instead of a catch. Okay, so essentially what we're doing is this. Set timeout function. I'm not using arrow functions today apparently, and we're going to throw this error. But we're going to throw that error after 2 seconds. And instead of catching directly here, we are going to put this function as a second function on the then. Okay, so that's what our plan was. This time, add the reject as a second argument or parameter to the then instead of catch. Okay, so then remember, as we had mentioned earlier, then can take two parameters. Okay, it can take the first one is the resolve, the second one is the reject. Sorry, I just want to let Daniel record. Thank you, Daniel. The second one is the reject. Okay. So this will, what's the difference between this and the previous one? Oh shoot, I deleted the previous one. What's the difference between this and the previous one? Anyone?
You're not passing the message to the then.
No, well, no, there is actually, the answer is there's no difference.
Oh.
This does the exact same thing.
The set timeout will run.
Yeah, two seconds later.
So when we make a then, it makes a new promise, like you were saying. Is that what it was? Or when you return?
It catches. Oh, actually, did it not catch that? Should have caught that. Let's reject. When we add a then, second parameters are catches. Oh, that's interesting. When I threw the error, it doesn't catch it, but if I reject it, it does. That's interesting. I didn't know that. Okay, so throwing an error doesn't catch it. So it's not quite exactly the same. There is a slight difference. Did not know that. So this is uncaught error. Oh, right. I know why. Okay, yeah. So there is a slight difference, and it actually doesn't have to do with, this does catch errors, okay? The difference is throw and reject are slightly different. Reject is based on this promise. Throw is, and again, you don't really need to know this, throw is scoped to a function, and throw, so that means throw is scoped to set timeout. Just a little thing. So reject, if you did reject, the answer is there's no difference. It does the same thing. Okay, so we'll do reject. We'll do reject up here. Just a little nuance, nothing major. Okay, number 2. The following functions returns a promise. Append to it a chain of 4 thens. In each, pass along a value, adding 1 each time, and log in the value to the console. Okay, so we're just going to do a chain here. This is actually 2. 1. So we're just going to chain some thens on. So if you notice, this is a little bit different. I declared it in a variable. Okay, so I can take that variable, add promise, and I can start chaining some thens onto it. Dot then. I need 4 thens, right? And I'm going to come back. I'm going to fix these. Just going to get my syntax out first. And I'm going to use arrow functions for this, a really simple arrow function, so it's nice and clean. So it's resolving. So it's console log into value, and it's resolving with 1. I mean, it really should be val, in all honesty, but it doesn't matter. Okay, what we're doing is we're taking that value and we're adding 1. So to accept that value in through resolve, right? It's the first parameter. So val, v, number, whatever you want to call it. And we're going to console log it. Console log. So it'll look better like this. Console log number. And console log number, and then return number plus plus. No, return plus plus number or console log number plus plus. Okay. We can't do return number plus plus because it will only increment the number after the return has occurred. Plus plus happens after this line is done. Okay, not during that time. So if I put it here, it happens after this line is done, so it doesn't actually pass the correct number. And we just repeat the same process. Okay, so we'll copy and paste this. And now we have 4 chains. So if I wanted to run this, I would say add promise 1. So I'd call it. Okay, I'd invoke, yeah, I'd invoke it and then call it with 1. And then we can just highlight this, press play. Oh. Am I just returning a new function? Oh, okay. Okay, that's fine.
Add promise doesn't have parentheses.
Yeah, do you need
The one with the
parentheses
floating.
Oh.
line 23?
Oh, yeah. Thank you. There we go. Ha. There we go. Add promise. Call it. There we go. 1, 1, 2, 3, 4. Okay. So to call this, right, you need to invoke it and it returns a promise. So you chain them on like that. Right. So this is returning. This is a function that returns a promise. So it becomes, after I invoke it, it is a promise, a running promise. And then I can just chain things right onto it. I could have just chained them. I could have just done this too. Taken this promise, this highlighted promise out and done that right here. Okay. And this chain would work on there too. Okay. And highlight this and run that. And that works too. It's the same thing. Okay. So I just removed the promise out of this function that was returning. So this is just a function, right? I'm just returning that promise, returning a promise. Or I can take that promise out and put it in. But there is value to wrapping it in a function. Okay. It doesn't run until that function is called. Whereas the other way, it just, as soon as it hits that block of code, it runs. And we're used to that by now. Okay.
John?
Yeah.
Can we, in the method, can we return a promise if we do not accept the parameter for them?
Over here?
In the method, can we return add promise in line 34? Yeah.
Line 34. Can we return a promise?
Yeah, add promise if we do not have a parameter for them. Return add promise.
Oh, return this.
Yeah.
Oh. Yeah, you should be able to. Let's try it out. And actually now we'll fix this up. So it's val. Okay, we're passing along val. So I think if you return a promise on your own, like a real promise, it overrides the promise that gets created here, I think. Let's try it out. So how it should go is it should go 1. I can get rid of this console dialog. It should go 1, 10, 11, 12. Let's see if that happens. Yeah. So you can create a new promise and return that promise inside the then. Never done that before. Okay, Q3. Q3. Using the previous block of code, add a catch. Okay, and then we're going to use a throw. Catch between the second and third then. Okay, a catch. So we're going to throw a catch in between the second and third then. 1, 2, right here. Catch, catch. So this is question 3. So I'm going to copy this actually before. Function. That. Okay, and this is going to be a message or a number. It really could be anything, right? Usually you're going to be catching an error, actually, right? That's probably what you're going to be getting. And we're going to throw a new error. So I linked to this document, okay, from Mozilla throwing the throw statement, okay, that you can just throw. Okay, you can just throw anything. This one is probably the most common, where you actually throw a new error. Okay, I'll show you what that looks like. So we're throwing errors already. Where am I going to throw this error? I'm going to throw this error to occur in the first then. Okay, sorry. I'm going to do it in here, in the first then. So we have already been throwing like this. Hey, I'm an error. But all we're doing here is we're creating a quote unquote error with an error, with a message, a crappy message. This is not a real error. This is a real error. And you can see, so new error means JavaScript has a built-in object class called error. And all I'm doing is I'm creating a new instance of that class and I'm throwing it. This is a proper error, okay? It will catch that error and we can console.log that error. Error here is an object. It has a message on it. Okay, so error, it's an error object and it contains a bunch of stuff about the error. Okay, a bunch of information about the error. So this is a proper error, in case you ever see that new error. This is just like a really simple, generic, okay, like nothing error. But either way, they will both fire the catch. Throwing anything fires the catch. This return will never happen. See how it's grayed out? Okay, so if I run this, error message. Okay, so that's what I put, throw error message. Console log error. But remember, it kind of tries to get itself back on track. Okay, and so it starts relogging things. Now, if I really wasn't able to get things back on track, then what I can do is I can raise that error up even further and I can throw it again to the next person. So think of throwing like you're throwing the ball. If you have a ball, you're playing catch. Okay, it's like a long line of people. You're throwing the ball to the next person. And the next, so it gets thrown from this then to the next person who can catch it. And that's a catcher. Okay, so we're throwing that ball to the next person. Now, the catcher is trying to like fix things up and get things back on track. But if they realize they can't, they're going to throw the ball. They're going to throw it, the error or the ball again to the next person who cares. And there's no one else who cares. And so finally, the last person who could possibly care would be the user. Okay, so instead of getting this, they were not able to get things back on track. If you throw an error again, okay, it will now bubble up. So it runs the first one, the error message is thrown and printed out, then they throw it again and it comes out as unhandled. There was no one left there to handle it. Now I'm going to report it to you, the user. Prior to that, there was no information being reported. Okay. And I guess the user, maybe the developer. Okay. You don't really need to worry about that though. Instead, what we're going to do is we're going to return 10. We'll get it back on track with the number 10. So if we did this, it would then take this value and push it onto the next then. Okay, if I got it back on track. If I don't return anything, I'm probably going to run into some problems getting things back on track. Sometimes you'll put the catch right at the end. That way you don't have to worry about trying to get anything back on track, depending on what you're trying to do. Okay. For now, don't worry about this in the bigger context. It will all become clear when you start to use it. Number 4, add another catch. Okay, if I add another catch at the end, which one does it fire when I do this this throw here?
First one.
Yeah, just the first one. The second one would catch any additional errors that might occur later. So if I were to throw that error again in this catch, it would be caught by this one. Let's print that out. Second catch plus error. So I can show you. So we throw an error message in this, then it hits this catch. We throw an error message in this catch, it hits this catch, and then we're done. Okay. So we added essentially another catcher, another person in that line, in that string. Okay. Error message, second catch error message. It jumps over all the thens. Okay. It's always going down and looking for the next catch. Does anyone else care about this error that just occurred? If you do, here. Otherwise, okay. Any questions about that? Okay. And finally, this last one. Okay. So we're going to use promise.all. And this one is not a necessarily easy one to understand or explain. So I think I'll show you. So pay close attention if you didn't get this, if you didn't understand the question or you didn't do it. Okay. So what I'm asking you to do is I have an array of letters. Okay. For time, good. I have an array of letters. Okay. And what I want to do is I want to console log these letters out. Okay. So I'm going to, but I want them to be console logged out in a very specific order. So what I'm going to do is I'm going to create an array of promises that are all running at different times, okay, asynchronously, using these letters. So this is a very kind of interesting, more advanced application of these things. It's applying this with something else that we've already done too. So I'm going to do a map. What does map do? Do you remember what map does? Who can tell me what map does?
Do something like return an array.
Okay, so map is going to return an array. This is really important. We're going to use tons of map. Map returns an array the same size as this, of the one you're providing, and each element is the result of the function. That there's going to be a function in here. Okay. The new elements, new element 1, new element 2, okay, is going to be whatever the return value of this function was. So it's going to, so this is 6 elements. This new one is going to be 6 elements. Each element is going to be whatever the return value of this function was, of this callback function was. And I get the element inside, right? It's like every other array method, element, index, array, right? You get those three parameters if you want. Okay, so I'm going to take that. What I'm going to return though is I'm going to return a new promise. So what I'm going to end up with this is going to be an array of promises. Okay, remember, map returns an array. I'm going to return an array of promises. And all the promises are going to do, they're going to call set timeout. And inside set timeout, we're going to console log element, the letter. We're going to console log the letter. After some sort of random time frame, which I gave you the time. So time is going to be math.random times 3000, some sort of random time frame. Okay, so this will generate a random time between something and something. So it's 3000. Are we console logging or resolving? We're resolving. We're resolving. Okay, we're resolving. We're not console logging. So what happens here? So actually, what I end up with, actually, I'm going to bring this over to my browser. Okay, so we've got this array of promises. So let's bring it over to the browser so we can see what it looks like. Oh, oops, I didn't pass in my resolve reject to my promises. I don't need reject because I'm not calling it. I just need resolve. So let's refresh this. Okay, so waiting a little bit of time. Okay, so I told you that promises is going to be an array of size 6, right? One for each element in here, because that's what map does based on the return value. So it is returning into each new element a promise that resolves with the letter that's inside of it after sometime between 0 and 3 seconds. So let's take a look at that array of promises. Promise, 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 promise. So 6 promises, right? So we're gonna take a look at that. So we have promise 0, A, B, C, D, E, F. Okay, cool. Now the problem is if I attached a then onto each of these promises, okay, which I can do here too, right? Or I can do it like this, promises, right? Because it's an array, promises not for each. We're gonna loop through that array of promises. Function for each. It's a promise, and we're going to attach promise dot then. And all then is going to do is receive that letter, and it's going to console log the letter. Okay, so if each of the things inside are promises, then I'm going to attach a then onto each promise, and I'm going to console log that letter. Okay, so let's see how that works. Play. AFB EDC. Let's try that again. EDB AFC. What is happening here? I made these in order. I made these promises in order. I'm iterating through them in order, right? And I know they're in order because when we looked at them from our inspector, do we still have that? Does that still exist? They were in order, A, B, C, D, E, F. I went ahead and I attached a then onto them. Why are they printing out of order?
They're all resolving at different times because you have a math random timer on them.
They're all resolving at different times because I have a math.random timer on them. Exactly. So in steps promise.all. Promise.all's job is to say, don't do anything until they've all resolved. And finally, after they've all resolved, then you can apply this then to each of them. So the reasoning behind this is because it is plausible and likely that we are going to want to do things in a very specific order that are not dependent, right? These are not dependent on each other. Printing out B is not dependent on A, but I do want them in a very specific order, okay? And they may take, the things that we're doing might take different amounts of times. So I want to respect the fact that like this might take 1 second, this might take 3 seconds, but I still want them to be in a specific order, the same order that I said. So promise.all guarantees that by saying, okay, what we're going to do is we're going to do our things. And then when we're all done, when the slowest person is finished, then we'll print the stuff out, okay? Which guarantees the order that we want. So promise.all takes a promise, an array of promises, okay? And one then. And inside this then, for promise.all, it is an array of all the values that it returned. So all these resolves get captured and stuck into an array. All the resolves. So let's just console log all the resolves. What do you expect to be inside this array? Think about it. You don't have to say it. At least think about it to yourself. What is inside this all the resolves array? And we'll print that out. The resolves. Resolve the letter. 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 All in order. The order is not relevant to the amount of time it took to resolve. The order is relevant to the order that you put the promises into that the promises are in the array. So this guarantees order, that I get these back in order, and that I don't start working on them until they're all done. So if I wanted to print them out now, I can just loop over this, because it's an array, just an array of strings. And we can print out the letter. And it prints it out in order, okay? Every year, students have a lot of problems with promise.all. So I know that, but questions?
Is there any way we can time log right beside each letter print? Like
how long it took?
Yeah.
Yeah, sure. Well, like, yeah, okay. So what we would need to do is we'd actually need to capture this information, the set timeout information. So we'll throw that in a const and call it time.
Give a variable.
And then we'll have to put time over here. We can console log time and letter, so we can see the timing and the letter, and then we'll see it reassembled. Oh, letter is not defined. What did I call it? Oh, the letter. So this is how long, this is the random number that was generated for each letter, how long each one took in real life. And then, so this is when it resolved in this order and how long it took each one to resolve. And then this is, so it waited, it had to wait, the whole thing had to wait for the letter A. Finally, once the letter A resolved, then this was able to run. So it's being blocked until 2.8 seconds.
Okay, thank you.
Yeah, you're welcome. Okay. Any more questions? Okay, I'll post this. I'm going to post this to the website right now if I can. See if it's up, and I'll also post it to Slack in case the website stops working, which it looks like it did. Discord. When I say Slack, I mean Discord. Oh no. Okay. I'll figure out a way to do this. Oh wait, it's a file. Okay. Reveal file in Explorer. Oop. In Discord. Okay. All right. So we're going to take a break from this. Okay. Tomorrow we're going to come back into promises, but it's not going to be in the same way that we're doing it right now. We're going to be doing something called fetch. So I ask you, I'm not sending home any homework tonight. I ask you, read the stuff that is sent. Okay. Because it'll give you a tremendous head start on the assignment this weekend, the exercise this weekend. Okay, so what are we talking about today? Today we are going to talk about essentially how the internet works. Again, okay? We talked about how the internet works a while ago when we first came into the course, but we didn't really dig in too deep because we're just coming in, right? So I talked about clients and servers probably. I talked about HTML. I talked about, the browser a little bit, passing information. Today we're going to dig in deeper. More specifically, we're going to dig into something called HTTP. Okay, and I'm sure you're all familiar with HTTP a little bit, right? Because you type it into your browser all the time. And so you know that all your websites start with HTTP. Right? So what is HTTP? So what are these things that go in at the beginning, pretty much, right? HTTP. Sometimes we'll see other things. What are some other things that we've seen that you may have seen that starts other than HTTPS, HTTP and HTTPS? What are some other things that you've seen at the beginning of your browser's URLs?
HTTPS?
If it has a certificate.
FTP.
HTTP, HTTPS, yes. Aside from those, have you ever seen FTP?
Yeah, and sometimes I just see like let's say you're trying to get to a router, you just type in just the IP.
Yeah, so just the IP is still HTTP, okay? FTP is the other one. So there's some other ones too. Sometimes you'll see file, and that's if you're opening a file locally, right? Like, I don't know if you could see that. I don't know how to zoom on this thing, like how to really zoom in. I don't know if you could see that. It's file, right? And that's a file local to my machine. Anyways, what are these things? These things are called protocols, okay? And actually, the word protocol is right in the name of HTTP and right in the name of FTP, right? File transfer protocol, hypertext transfer protocol, HTTP hypertext transfer protocol. Okay, a protocol is essentially a set of directions, guidelines, okay, for how we perform the transfer of information over this particular protocol. Okay, so HTTP, Hypertext Transfer Protocol, a set of rules for communication over HTTP. The basics behind HTTP is it allows us to, it's one way, not just, it's not the way, it's a way that allows us, clients, like users of the internet, or programmers too, to have one computer talk to another computer. Okay, and that's essentially what the internet is, right? It is one computer, our computer usually, going to another computer and asking for a web page. And then that computer responding with, here is your web page. Okay, now that's a very broad description of it, right? And that encompasses a lot of stuff that's going on. So we're going to talk a little bit about how that actually happens, because starting tomorrow, we're going to be actually doing some more stuff with HTTP, right? We are actually reaching out to other computers and pulling in information, not in a web browser, not in a way that's abstracted away from us. A web browser is really abstracting a lot of the hard work away. Web browsers are very complicated, actually. Okay, they're doing a ton of work in the back. And we're going to dissect a little bit of that today, just so we can understand how this information is communicated over HTTP. It's not going to be super, super difficult, and I hope you find it really interesting. This is the first time I've ever done this with a class, okay? I thought that this would be a good opportunity. So generally, how HTTP works is it's a request response. So request, I ask for something. Specifically, I ask for an image. I ask for a file. That is usually how it's going. When we are at a website, what we are actually doing is just any website, right? I just picked one at random. Let's work on mitt.ca. That's always a good one to work on. Okay, so we're gonna look at mitt.ca. What I'm really doing here is I, the client, like the browser, am typing in a URL, and this URL goes out and it finds another machine somewhere, a server, and it asks for a file. Does anyone know by default what file I'm asking for right here? mitt.ca. You don't see the file name on here because it's implicit. Can anyone take a guess?
Index.html.
Index.html.
Yeah, if I actually typed in index.html onto here, there's a very, it's not guaranteed that it's index.html. Usually it is, but there's a very high chance of it being index.html. I bet you it's probably index.php. No, okay, well, it's a web page. Okay, websites are allowed. Websites are allowed to serve up a page to the browser by default without specifying what, like on their end, they are saying, if you don't ask me for a specific web page and you're asking me at this directory, I will give you this one. I will give you a default web page. Okay. So the process though is we are requesting something from that server, and they are responding to that request. Okay, so it's a request response. So we say, hey, give us the web page that's located at the root. Okay, so before we get back into the request response stuff, let's talk about URLs. Okay, because URLs are really super key and they're the beginning to all this. So when we're breaking down a URL, where's my URL stuff here? There we go. When we're breaking down a URL, we essentially have a few parts. We have the first part, and this is the part that we're familiar with all these parts. Okay, but I'm going to tell you what all these parts do. We have our HTTP or HTTPS. Okay, this is our protocol. Our protocol. One means it stands for Hypertext Transfer Protocol. The S means the data that we're sending and receiving is encrypted. That's what the S means, okay? It's encrypted. The no S means it's not encrypted. That's our protocol. The next thing we have oftentimes is if we took like a regular URL, let's say http://www.google.com. What's the next thing we have here? Does anyone know what that's called?
World Wide Web.
Yeah, that's what it stands for. Okay, but do you know what it's called? Have you ever seen something like this? You ever seen this website URL before? I hope you have, because that's the website for our website. That's the URL for our website. Okay, is this www the same as this? The answer is yes. Okay, these things here that occur before the name of the website. Okay, so actually, a lot of times I find it's helpful to read it from the back, from this way, going right to left, because you can have as many of these things in front as you want. Okay, totally allowed. Totally allowed. And actually, this is how phishing scams work pretty often, is they try to obfuscate the actual real name of the website with a bunch of subdomains. These things are called subdomains. Okay, they are just additional little things that you can put in front of the URL, but they can only be managed and they're owned by the people who own mitt.ca or google.com. These are the actual domains, mitt.ca. So mitt.ca, google.com. The way you can actually tell is you go to the end and you look and it says .ca. Okay, that is the top level domain. After that, you have the slash, right? After that, you have the slash. So you go to the slash, you find this piece here, and that is the real top level. That is the real domain. So these are the top level domains. This is the real domain, google.com, mitt.ca. You can have as many things in front of it with as many dots as you want, but the real domain is mitt.ca. Same thing with google.com. www is just a subdomain. It is literally no different than this. What is a subdomain? It's nothing really. It's just like we own google.com, but we want to separate docs.google.com or drive.google.com. We want to make logical separations of all the stuff we have under google.com. So we want to do that. We want to do subdomains. Sometimes you might see it like this too, right? Or music. Okay. So these are subdomains. When they're in front of the domain, music.google.com, drive.google.com, they're called subdomains. And they're just a way to take a domain and break it up into different pieces. It's like if you had this beautiful house in the Hollywood Hills and it's so big, you've got a pool house and you've got this and you've got that, right? You've got all these separate other houses under one address. Whoops, right? Under one address, okay? Kind of like an apartment block, right? Apartment 1A, 32 Stratocaster Lane. I don't know. Okay. That's what subdomains are. These are the domains are usually the actual servers. So when we're requesting google.com, we're going to the Google servers. Now, which actual server at google.com are we going to? We don't know. They have millions, right? They have a lot of servers to handle a lot of people. And so we don't actually know, but we're making a request to google.com. Any questions about, so this is the protocol. This whole piece here is considered the domain, including subdomain, everything prior to the actual name, and the top level domain .ca, .com, .org, .net, .developer, .code, .beer, whatever. Okay, there's a bunch of new top level domains out right now. Any questions on those? Cool. All right, next up. After that, this slash represents the root of the folder on the server where the website exists. So this actually points not only to a computer, but an actual folder somewhere on that computer that they've designated. So it goes to the computer, it hits that server, and it says, oh, okay, you're requesting part of this website. That whole website exists in some folder on the computer. So maybe it's this folder. Okay, maybe it's this lessons folder. So root would be starting here, the lessons folder slash. So if I wanted to go to a specific page in this website, it might look like lessons %20 for spaces 1, or lesson space 1, right? That would bring me to this lesson. That would bring me to this lesson folder. And then maybe I want to look for index.html in that folder. Okay, so that's where this URL, that's where these are subfolders, all these slashes. This is the file that we're requesting. Okay, index.html in that folder. If I wanted to go to a different folder, maybe it's lesson 2. Now, we are not actually, a lot of this is abstracted away from us because they name their folders in such a way that they're, like, they're not folders. They're like names, programs, post-secondary programs. There are website structures that are properly named for people to be able to memorize and type in well and stuff like that. They're not the same type of stuff that we do on our machines, but in reality, that's what they translate to. So literally, there is on the machine that exists, there is a folder called programs and a folder called post-secondary programs and a file in that folder called index.html or index.php, or I'm not exactly sure, but we can find it. We'll find out shortly. Okay. So that's how these URLs, that's why these URLs play such an important role in the internet, because they tell us which computer to go to, what file specifically we're requesting, in what folder. Are we encrypted or unencrypted? So we're talking about this request response cycle. We're giving all the information that we need to inside this one little piece of information, inside this one little URL. It's a path. It is a path to a file on a server somewhere in the world. Okay, and it's been so well and intelligently designed that it works so well. Okay, in addition to that, okay, so this is the path. Okay, subdirectory, subfolders, the whole thing is the path. In addition to that, sometimes you see these things. Let's go to google.com. Let's make it a little search here. What is REST? We're going to take this. We're going to paste it in here. And it's giant. Sometimes you see this crazy stuff at the end, right? Question mark, things, equals. There should be an ampersand somewhere. Ampersand, okay? So these are called query strings. Query strings. What they are is they are a way for us to pass information into the web page. So far, the way we've been dealing with accepting information from the people who are using our page is they come to our page first, and then they push buttons or they put stuff in the box, right? That's how we've been accepting information. But we can actually take in information and pull it directly from the URL. One, we can read all this stuff in JavaScript, okay? But there's actually very specific pieces of this URL that are designed to provide us with information if they're available. And they all occur after this question mark. You are allowed to have one question mark per URL. Everything after that question mark is considered no longer part of the actual destination anymore. Where, which folder, which computer, what server, right? Everything after the question mark is actually considered parameters. Okay, there's that word again, parameters. They're parameters. And they work like key value pairs. So I can have a parameter like this. Name equals John. And so when someone comes to my website, I can actually pull that information right out of the URL. And I can start doing stuff with it. So if you imagine like our pig game or like any of our stuff that we're like, okay, and I say, okay, ask the user how many of these, or make them push a button, make them enter information. We can actually pull that information right out of the URL. So when they arrive, we start processing right away. We don't have to wait for the user to do anything. We can start processing right away. And this is how Google a lot of the times work, right? It takes, when I type something in here to this box, okay, and I hit submit, it creates a new request for it links me to a new web page entirely. It did not remember who I was the first time. And all it does is it passes that information in this box. I wonder if I can see it in here. Yeah, right here. Okay, so here is the Google thing. And here is my question. What is REST? That's my query. It's actually in the URL. So that means if I took this URL and I posted it in Discord for you and you clicked on it, it would give you the exact same results. It doesn't know that I'm the same person who asked it 3 seconds ago, what is REST? Like the web servers don't make that connection. They don't care, okay? This is called statelessness. There is no state, right? I don't have this permanent connection where we're constantly in this conversation, me and the website. It doesn't remember, okay? It has no state. Okay, so we're coming back over here. We're talking about query strings. Where am I here? Okay, so they're using very complicated codes for their query strings because they probably don't want people to figure out what information they're passing. Fine, no problem. Okay, a lot of websites use very simple ones. Okay, you can, and to separate these key value pairs, you put ampersand. So name, age, we're all familiar with this type of stuff, right? So I just passed in 3 pieces of information into this website, this web page, okay, google.com search. Now, it probably doesn't care. If I took this and I dropped it in there, it doesn't care about the pieces of information that it doesn't care about. It looks for the stuff that it cares about because it's controlling, it knows what it's asking for, right? It knows if you cared about these things, you can go pull them out. If you don't, they don't do anything, right? They just sit there, and that's fine. We would often be the ones placing these on the URLs. So that way we can pass information from one web page to another for the user, right? And you can see that happen often in web pages. I wonder if there's some web pages on here that have, I can almost guarantee there are some pages on here that have something going on. Email us. No. We'll find one. We'll find one. Okay. Those are query strings. So that's your URL. That's a URL. 10 o'clock, hey? Whew. Okay, we're getting there. So these URLs are used to point at very specific files on web servers. They can be anything. They can be HTML files. They can be JPEGs. They can be whatever, music files, right? It doesn't have to be .html. It could be some song.mp3. Okay? And if there was a file that existed, some song.mp3, it would request that file. If your browser can handle that file, like browsers can now handle MP3 files, and the little music player shows up right in the middle. Back in the day, they couldn't, and they would just be like, here, do you want to download it? Okay, so that's a lot. That's what happens now. Like PDF files, they weren't able to handle before. Now they can handle. So if you request a PDF file, it just shows it in the browser. Back in the day, it used to just download it. Or you can tell your browser to do certain things with certain types of files. So that's where the URLs come in. Okay, they point to the place and the file. All right. So let's talk about mainly two ways that we can get and send information. So I showed you one way, and that is in the URL. But you can imagine that if that's how I need to send information to a web page, if that's how I need to provide information to a web page, that's fairly insecure, because all the information is just available in the URL in plain text, right? So when you're thinking about things like a form, right? So here at the top, here is a form, okay? So I can type in stuff. What am I gonna type in? Test, and I'm gonna hit find. And you notice there was no information passed into this page from the URL. If you can't see that, let me post it into here. Here's the URL that I'm dealing with. There's nothing in here, right? There's no question mark query equals test, which is what I asked for. Because there's two ways of providing information. Providing an information in a request. Method number one. So what I'm doing, okay, what's happening here, when I click on this magnifying glass and I do this, and I hit this magnifying glass, this is what's happening. I am requesting a new page. And again, it is stateless. It does not know that in 1 second, when it returns this page, that I am the same person that hit this magnifying glass. All it knows is that this computer at this address asked for this web page. That's all it knows. Everything that happened before and everything that's yet to happen, it does not know about it. It only knows what's happening right now. And so it needs to have all the information. So this piece of information in here needs to somehow get passed to the server in that request. And it's not in the URL, because that's, again, when we're requesting things, it's in that URL, right? We're requesting a specific file. So how is this data getting passed to the server if it's not in the URL? The answer is inside what we call a post. Everything that we've been doing so far with the URL, that's called a GET. There's two types of main requests that web browsers do: posts and gets. A post takes all the information inside the forms or any other information that we want to wrap up, and it puts it in a little special holding place that we can't see, a little package. And it takes that information, and along with the URL, it wraps it up with a bunch of other pieces of information, and it sends it to the web server. And then the web server receives that information and unrolls it and looks and says, okay, so this is the page you're requesting. This is what your IP is, so I know where to send it back to. This is the data that you provided me with that request. Okay, I know what you're asking for. Let me generate that HTML page for you, and poof, send it back to you. And it linked me to this URL. Well, this is actually the URL that I requested. Let's take a look at what a post looks like. So far we've been using, so these things these terms that I'm using, post and get, these are verbs, HTTP verbs. Okay, there's actually 7 of them. The main 2 ones that we care about are post and get. That encompasses like 95% of all the requests that occur. The other ones are mainly for development purposes. We'll look at them though. So we're going to inspect this. We're going to look at a new tab. I will actually take you through this tab later a lot. The network tab. And I'm going to refresh this. We're going to get rid of that. This is everything that occurred on this page. All the images that were loaded, all the JavaScripts that were loaded, all the requests that occurred, even the request for this page. So we're going to look for document. So this is the request that I made to get to this page, search result, mitt.search result. I'm going to open it up, and we're going to actually look at the request and the response from the server that came back. So I did the method that I did was a post. Okay. It knows the address. Okay, the IP that we're communicating, like I have an IP, it has an IP. We need each other's IP. So I send it information and it knows who to send the information back to. And then way at the bottom down here, these are called, so this is the request. This is the response. So there's a bunch of additional information besides just the file. Okay, but right at the bottom, you can see form data. And then the little thing that I typed in there. So it's actually being packaged up and put into this request. It's actually part of this request. It's just being separated out of here. Now, I can see this because I'm a developer. You can see this on your own computer, but because that little lock exists, that means this data, when it's transferred, is actually not visible to anyone. That's what that encryption means. So this data, so when you're putting in your credit card information, when you're putting in your name, when you're putting in your address, you can look at it on your computer because it's your computer and you have one half of the encryption, so you can unencrypt it. The other computer has the other half, they can unencrypt it. But everyone along the way, if they ever decide to look at this information, because this is the information that would be transferred and everyone can look at, it's encrypted, so they couldn't see it. That's what the S stands for. That's what this lock stands for. Okay. And that's how that's why if you don't have that lock, all this information is visible to anyone who's watching traffic on a router. You can actually see all these requests and responses be passed to and from different websites sitting on a router. So if you looked at the request responses, you can see all that data being passed around. You can see all the URLs. You can see all those variables in the URLs. Super important to have that lock there. That's why SSL is so important. So I made a request. Okay. I made a request for a specific page. I actually didn't. I pushed that magnifying glass, and that magnifying glass made the request for me on my behalf. Okay. It says where I came from. It says where I want to go. The page that I'm requesting, request URL. It passes in this data. It knows where it's coming back to, right? So that IP, okay? And it's able to figure out, okay, they want this page in this folder. They pass me this data. I want to do some calculation stuff on my end. And boom, generate an HTML page. Here you go. Okay. That was a post. The other type that we're very used to is GET. And GETs are like 99% of all requests. Okay. If I just click on this link, okay, I just clicked on a random link, high school options at MITT. So we'll click on that. That was a GET. All I'm doing is getting information. I'm not really sending anything. This search could have been a GET as well. And they could have put that little question mark with the search criteria in the URL, and that would have worked fine too. But usually with forms, when people are pushing submit on forms, usually that's submitted via post. And that's why we haven't done anything with them yet, okay? We can't accept posts with JavaScript, actually. We can only accept GETs. We don't accept anything, right? We execute after the page loads. Okay, so HTTP verbs, GET and POST. POST is mainly used for forms. GET is mainly used for everything you click on. Every other thing that you click on is a GET request. Okay, I'm asking, get me this, get me that, get me that, get me that. Okay. Then below that, we have this thing called a status code. Okay, and we're going to be dealing with GETs starting tomorrow. We're going to be dealing with status codes starting tomorrow. We're going to be using URLs to ask for specific data starting tomorrow. Okay. Status code is, did this work? Okay, did what you asked me for worked? We're familiar with status codes, believe it or not. What's the most common status code that you see?
404.
Yeah, 404. What is 404?
Error.
No, 500 is error. Okay, so there's a
Not
bunch
found.
of
Not found.
Not found. So that happens when we try to access a file on their server that doesn't exist anymore. So to do a 404, all I need to do is slash random stuff, enter, and boom. I get a page because we can still provide pages to them, right? But we're also giving them, this is a specific type of response. And you can see the status, it's a 404. And so what that tells the browser is like, okay, this happened. It's not just telling the browser, it's telling anyone who cares. Now the browser doesn't really care about it because it's passing along a page with it. So it's saying file not found, here, go here instead, right? But when we're going to start working with these things from a programming perspective, we are going to care. Did we ask for something that doesn't exist? Can we maybe fix that in our JavaScript, right? So you get a 404 not found. So there's probably about 50 different statuses, okay? There's statuses in the 100, statuses in the 200, statuses in the 300s. I have a short list of the ones that we really care about. We really care about 200 and 201. So 200 is okay. From a web browser, that's probably the most common one. The two most common ones from a web browser are 200 okay and 404 file not found, right? Those are the two that occur in a web browser most often. But when we're going to be working with HTTP starting tomorrow, we're also going to care about 201s created. So we're going to ask, we're going to say, hey, server, I want you to create this new piece of data on you. And we're going to give it all the information. And it's going to say, 201, I created it. Okay, that's how it's going to reply. Okay, or it could reply with 200 okay, depends. Actually, we also deal with 301s and 302s pretty often in web browsers. 301s are moved permanently. So you saw this happen. I go to google.com. Hit enter. And then I come in here, I type something in. Oh, it didn't redirect me. Okay, I would have expected, or does it? And I don't see it. Yeah. It does, and I don't see it. Chrome's just really good at hiding it. I typed in google.com. It actually, behind the scenes, redirected me to www. That was a 301. So when a 301 happens, it's transparent to us, but the browser does some stuff in the background. So we ask for Google, and then it says, actually, no, Google wants all its people to go to www.google. So we're just going to ship you over there. That's a 301. Move permanently. 302 is move temporarily. That occurs sometimes. 401 is unauthorized. So sometimes when those pop-ups come up and you try to log in and you are not authorized, 401 or possibly 403. Okay. 404, file not found. 500, something happened and it was an error on their server. So probably their code broke. And 503, service unavailable, that usually happens when a website is down. Not like in our case. Okay, in our case, it's just not responding. A little bit different. That one doesn't have an error code because there's no, the server needs to reply with these. If the server is down, there's no reply. Okay, those are statuses. So we've got a status, we've got URLs, we've got get and post. Okay, and remember, the websites don't remember who we are. How does Amazon know that I'm this person up here and I have two things in my cart? How does Amazon know this? Can anyone speculate?
Cookie?
Cookie.
Yeah, cookie. So when I come here and I make a request, it looks in my cookie. It pulls out information and it uses that information and it looks it up in its giant database of stuff and it says, oh, okay, you're this person and we have some information about what you have in your cart. So we're going to build you a custom website with those pieces filled out for you. If I delete my cookies, and so every time I click on a new link and I request a new page, every time it's always reaching in and looking, did not mean to click on that. It's always reaching in and looking, it looked at my cookies and it repeated the same process. It didn't know from the last click on the homepage that I'm the same person as I am now. It does not remember. Every single time I hit any URL on Amazon, it does not have any memory at all. It has to repeat the same process over and over and over and over again. It's crazy. It's crazy. And that's how the web works. It's stateless. Okay, so it doesn't maintain state. It doesn't maintain this long-standing memory of what happens. So if I were to go and delete my cookies, okay, so let's take a look at my cookies. Here are my cookies for Amazon. And if I clear my cookies and I refresh this page, it doesn't know who I am anymore. Doesn't know what I have in my cart. It doesn't know anything because it actually doesn't know anything. It's looking for cookies. It's looking for information. No cookies, no information, cannot customize a page for me. Okay, because it doesn't remember, because it doesn't have any memory. I mean, it has memory in the traditional computer sense, but the web is stateless, unlike a lot of other things that we can do in programming, okay? It's stateless. Questions? Nothing. how did that go? How do you feel about this? Are you confused? Are you enlightened?
Yeah.
Which
the
one?
last one. Enlightened.
Enlightened?
I
Okay.
actually had somebody ask me before, when I had gone over some of like the assignments and stuff we did. He asked us if we had gone into state and stateless like stuff yet, and I said no, but I read a bit about it and it was interesting.
Well, yeah, we're just going to start to get there now. It's not really part of the curriculum. I'm not really going to cover it, but like, it's kind of one of those things where we don't really talk about. We figure it out. We're like, wait a minute. So we don't know if the person who's coming to our website right now is that same person who was just there 5 minutes ago. The only way we know is by the cookie. And we're actually not making that thing. We're never doing that. In the code, we're rarely saying like, hey, are you the same person that you were 5 minutes ago? No, we take this information in and we go to our database, we pull information out and we customize this page and we display it. And we don't ask who they are. We don't follow. We don't know how long they've been on this page for. Like, we don't know any of that stuff. We don't normally, like, we could find that out, but we don't normally care. We have constructed this way of dealing with statelessness very easily. It's actually quite easy to just like, we'll just put little things on them. And then when they come in, we just know who they are. We just pull that information right off of it. And every single time we request a page, every single link click is a request, right? So we're able to figure that stuff out. And we'll start to get a little bit more comfortable with this. I'll go through this network tab a little bit more with you next week. I think it's pretty interesting. There's a lot of interesting stuff going on here. Okay. When we look at all the stuff being loaded, this is all the stuff being loaded for this page. Images, JPEGs, JavaScripts, everything. It's lots of stuff, right? There's hundreds and hundreds of stuff. So I'll go over that with you next week. But for today, all you have is reading. So if you didn't read yesterday, I've got reading on status codes. Okay, again, there's not a lot that you really need to, you don't need to memorize all this stuff. I just want you to be like, oh, okay, I get it. I'm familiar with them. That's it. You don't need to memorize it. The ones that you'll see the same ones appear over and over and over again. 200, 404, 201. I want you to take a look at what is a URL. So again, a little document that breaks down the URL into different parts. Okay, that's super useful. What else we got here? HTTP methods. So I only looked at get and post. The other ones that we're going to look at probably are put and delete. Okay, and then I put an article up about REST. There's actually a lot of reading. REST is tomorrow, I think. Fetch. So tomorrow we're going to do fetch, which is a JavaScript thing. Okay, and so this is going to tie promises and this stuff together. And we're going to actually make requests to web servers from our JavaScript to load data. Okay. Yeah, so do all that reading. No exercises for today, except for this afternoon. We're going to do some new stuff today. But yeah, tomorrow's an awesome day. This weekend's got a really cool project. Got some really great stuff coming up next week. So look forward to it. Okay. All right. If there's any questions with the readings or anything that you want to talk to me about, just shoot me a message. Let me know. I'll be online. Other than that, I'll see you at 12:30.
See ya.